So we want to finish our discussion of the black hole-like solutions in general theory of relativity with a discussion of another very complicated and subject on which there is no generally commonly accepted opinion in the scientific community. So let me phrase the problem that I want to address. We have obtained the following Penrose diagram describing the collapse process. The following Penrose diagram which describes the collapse process. Let me draw it clearly. So we have the following situation. So this is a region which is inside the star, in the body of the star. So consider some observer which stays always outside of the star. Its world line is like this. So from the point of view of this observer, the collapse is never ending. So the surface, the last light ray, which is emitted or refracted by the star, goes along the horizon and reaches the observer only at its future infinity. We have seen this effect in many different situations, in many different calculations, that a body which is falling inside a black hole, it takes from the point of view of outside Schwarzschild observer, it takes infinite time, etc., etc. So there are different ways to see this phenomenon. So then appears a very obvious question. Well, of course there is always event horizon. For the collapse process, there is an event horizon. This event horizon is present there always. But the question is whether the black hole, from the point of view of the matter, the body of the black hole, the matter which creates a black hole, the point is if from the point of view of the observer which stays always outside of the black hole, the question is whether this creation happens during finite period of time or not. You see that we observe the following situation, that basically the matter which contributes to the black hole from the point of view of outside observer always eternally stays outside of the horizon. It never crosses this. So I want to establish a few things. First of all, I want to clearly state the approximation in which this statement is valid. And then I want to propose my, not generally accepted, opinion on what is going on. I want to convince you that the creation of the black hole happens within finite time, even from the point of view of those who are staying eternally outside of the black hole. Why? The reason is the following. This statement, so suppose we have a star which is collapsing, and suppose we have, it emits some radiation, or refracts some radiation, which is detected by someone staying outside of the black hole. One may say why I address this question, because this radiation experiences this exponential redshift. The frequency experiences exponential redshift. So there will be no device which is capable to detect this phenomenon. But you see, this exponential factor is crucial for many phenomena that are happening in the black hole. For example, this exponential factor is crucial for the Hawking radiation. So due to this exponential factor, we have the Hawking radiation. Of course, one may say that there is no device which can detect this, but the Hawking radiation is exactly due to this factor. So I think that the discussion I'm conducting is important to understand deeper the Hawking radiation and the back reaction on it. So that's the reason I'm discussing this phenomenon. Again, there is a radiation which is refracted or emitted by the body of the star and detected by this guy. The fact that this radiation, how you call it, if it is emitted in equal periods of time, is reached by observer, but the time is increased. So the periods these are periods becoming bigger while these are fixed. That can be seen from different ways of calculations and is related to the fact that the time slows down as from the point of view of this observer, every process on the star surface slows down. But this statement is obtained in the following approximation, in the approximation that light rays are going along light like geodesics. Light rays are going along light like geodesics if they describe a probe, if they describe such a situation that we neglect the fact that light ray carries energy and also curves space-time. So basically this space-time describes the following situation, that it is curved by the black hole, but we neglect the fact that it is curved by the observer or by light rays. The question is whether this neglection is meaningful when we discuss such an exponentially suppressed phenomena. And I am trying to explain to you that it is in fact important to take into account the fact that light rays are also bending, curving the space-time because they are carrying energy. And if we take into account the fact that light rays also are contributing to the curvature of the space-time, the process looks a bit different. Let me clarify this point on the picture that we have described in the lecture 4, in that lecture where we have obtained for the first time Schwarzschild solution. In that lecture, we considered the light-like geodesics in the Eddington-Finkelstein coordinates. So there was a peculiar, so this is, let me say that this is a singularity, r equals to 0, this is r equals to rg. And then we had the following picture. We had outgoing light rays behaving like this. And inside they were actually ingoing. And there were ingoing light rays, like this. So that was the picture that we had already. Now, this picture describes geodesics, describes light-like geodesics. And it neglects the fact that light rays carry energy and also curved space-time. Of course, if a light ray carries energy, if we take into account that it carries energy and also curves space-time, it goes along a curve which is actual light-like line, world line, rather than geodesic, which is, for the small energy carried by light ray, is a little bit different from this guy. So those will be a little bit different. Of course, this picture is not applicable anymore in that circumstances because in this case, the picture is stationary, so it repeats itself at every different moments of time. It's stationary. While if we take into account the fact that light rays also carry energy and curve space-time, the situation becomes non-stationary. But approximately for short periods of time, if we discuss only seeds of light rays, in that case, we have a very similar picture. But light rays are actual light rays are a bit different from the geodesics, are a little bit different from the geodesics. But now what do we encounter? In the original picture for the geodesics, we had the following situation, that this vertical line, which corresponds to the horizon here, was also one of the light rays. So if a light ray was standing on this line, it eternally stand on it, eternally go along it. But if we take into account the fact that light rays also carry energy and bend curved space-time, the picture will be similar. We will also have a family of outgoing geodesics that are in this region are going to infinity, in this region are going inside. In the seeds, we will see that. For the seeds, this will be apparent. for the seeds will be apparent. But it will happen that this light ray will either belong to this family or to this family, but will not eternally stay on this surface due to the fact that it also curves space-time. So it will contribute to the emission of gravitational waves or something, some other stuff like that. So let me rephrase this, what I'm saying, in different terms. I'm saying the following thing, that if this guy emits radiation which is received by an observer which stays always outside the black hole, this observer will see the very last Zug, the very last wave packet emitted by the star, and the one which is after it will contribute to the body of the black hole, to the energy of the black hole, and will not be received by this observer. So this observer will stop receiving light rays from the collapsing body. Will stop receiving light rays from the collapsing body within finite time as measured by this outside observer. So this moment can be considered as a moment of the creation of the black hole. Of course, this definition that I have gave to you, this explanation that I have gave to you has some drawback, because the moment of the creation of the black hole is somehow related to the energy carried by this light ray. Stronger is the energy carried by each wave packet, earlier the creation is happening. This is a drawback. And of course, I'm vaguely explaining to you the picture which demands some further rigorous study and explanation. So I just gave you the idea, my idea, of what is going on and why the creation of the black hole happens within a finite period of time from the point of view of outside observers.